All right. Hello, everyone. Welcome again to the Project Pavilion and to the wasmCloud community meeting for Wednesday, November the 13th. We are going to be getting started here with a presentation. We're going to talk about wasmCloud as a project and then get on to a quick demonstration of what wasmCloud does and go from there. So wasmCloud is a newly incubating project in the CNCF. We're super excited. We just hit that tier. We just hit the incubating tier recently. There we go. I can actually hear myself better. Everybody, please come in for the Project Pavilion demos. We're going to start with wasmCloud. And we are a Wasm native orchestrator for deploying applications to any cloud edge or platform. So just to give you an idea of what we do with wasmCloud, developers can write business logic in terms of native code like Go, Rust, TypeScript, and then compile that to a WebAssembly component. WebAssembly components are a lighter weight abstraction for a lighter weight binary target. So instead of building an application and hoisting that in a container and then deploying that, our unit of compute for wasmCloud is actually this Wasm component. I've got a couple demos to show you what it looks like to build components today, but I think you'll find that it's just like writing a native binary. Now, once you've built your component, you can then compose it with these open implementations of capabilities. And this truly allows you to do an interface-driven development model in terms of capabilities like key value, blob store, HTTP, or even your own custom implementations. And this lets you only redeploy and retest your app when you actually want to add features or fix a bug in your code. You don't have to do it for all the open source libraries that you take. Now, once you've built your application, you can then run it on any device, any edge, or any cloud. We use the CNCF project NATS, which is somewhere out here, somewhere out there. You can go see the NATS booth in order to do cross-cloud, wildly distributed RPC using the WebAssembly component model directly. So since the last time we were at a KubeCon conference, we are now an incubating CNCF project, which is really just a testament to our community, to our industry adopters who are using WebAssembly in all kinds of ways, and the growth of our vast community and contributors. So, over the last year, we've increased the number of monthly active commits and users by over 100%. Love using, the 2x, the 100% stat. And we're also continuing our commitment to standards. So without getting too far into the slides, I want to talk about all the things that we've done with wasmCloud over the last year. But why don't we go ahead and get into the demo? So what I want to show you today is your first WebAssembly component. This component is written in Go, and we're actually compiling this using TinyGo and using the wasmCloud shell wash, the wasmCloud shell tooling to deploy this on a local development platform. So right when we get started, if we wanted to take a look at some of the code, we have this handle request function, just uses the net HTTP, response writer and request. And we have just a simple root handler here. If you hit localhost 8000, go hit that in the browser, we get our nice little welcome to the Go server, right? And nothing too fancy here, right? I'm writing HTML back to the response, which is great. Now, this component is just a regular native Go app. And when we compile, instead of compiling to a native target and then running that like with Go run, we're actually running this with WebAssembly as that binary. But you'll notice you don't see anything different as you actually deploy the app, which is great. Let's go ahead and make a couple changes to this and look at the hot reload flow of wasmCloud. So the first thing we can do, we can actually uncomment one of these handlers here, like the proxy handler. And as that rebuilds, we're actually going to take advantage of a couple of unique aspects of WebAssembly applications. So you'll see here, right when we built our application for the first time, we say that we detected a dependency on an HTTP server. We're going to handle incoming HTTP requests. And wasmCloud was actually able to deploy that local infrastructure and say, hey, we're listening on port 8000. All requests that go to that port will now get sent to your application. If we look at the dependencies that we have after we uncomment the second handler, we take a look at that implementation. What we're actually doing is we're checking the request header for a proxy URL. And then we're actually going to use an HTTP client. This HTTP client is just the net HTTP client. and we're going to send a request to that URL. So we're basically implementing an HTTP proxy here. But now we have this other dependency on HTTP client. So if we do something, I think I actually need to do this one in the terminal. If we curl our regular endpoint, we get that HTML. If we send something to X proxy URL, like you see I was doing this before, HTTPS example.com, we'll actually see that we get a request or a response from example.com. This was actually proxying fully through our WebAssembly component using those capabilities. So this is great. More there. We can also go back. Let's add a more common microservice capability in key value. So I will change the implementation of this handler. And what we're going to do is, I think I uncommented this out over here. We're going to add one more handler at /hello that every time we hit that HTTP endpoint, we're going to open a key value store. And then we're going to increment the value at a counter called hello. So we're interacting with a key value store. We don't actually know which key value store we're going to use. We just know that that is a capability of our application. And we look at this. I have a compilation error, right? Why? So if you take a look at why this is happening, we added a new capability to our application, but WebAssembly actually operates in a deny by default sandbox. All the capabilities that you want to use at runtime, you have to declare upfront when you're building your application. So when I went from this HTTP app, which I already said I was going to use, to something that used key value, this actually failed to compile. And then, even if you got it to the point where you could compile this app, this actually failed to instantiate at runtime. This deny by default sandbox is incredibly powerful for building applications in the cloud, which are secure by default, very fine-grained capability control. So all I need to do is update our interface dependencies here in this WebAssembly interface types file. So I say, hey, I am going to use this key value store, this key value atomics abstraction. We can see now that I have a dependency on a key value store, and we can curl I'll probably just type this one out. We can curl our hello endpoint. Ran this demo before, that's why it says 17. And we can keep getting that counter, right? Amazing. We've written this like Go microservice, which uses HTTP server, client, and key value to actually run as a WebAssembly component. Now, you've probably seen something like this before. So I want to talk about why this is so special. When we're deploying the local infrastructure to actually run this demo, you may have seen something like this happen in an infrastructure from code motion, right? Like we write out that we have a dependency on a key value store, and then so your tooling can take a look at your code and see that, and then deploy that infrastructure for you ahead of time. What we're doing with WebAssembly is actually way more powerful. We're not looking at the code at all in order to deploy that local infrastructure. What we're doing, what our tooling is specifically doing as a part of the development loop, is inspecting the WebAssembly binary itself, which is your application artifact. This is the built WebAssembly component, and seeing, hey, I have a dependency on a key value store, I have a dependency on an outgoing HTTP handler, and I have a dependency on an incoming HTTP handler. So this is not an infrastructure from code motion. We're not interpreting the source code. We can actually provision this platform just from the binary itself. So this has huge implications for platform engineers who want to run developer applications, but when they get shipped a container through CI/CD, you build your container, you build your application, you put it in a container. That container is a black box. You don't know anything it's going to do at runtime, but WebAssembly, with the same user experience, gives you all of the information, all of the APIs that it's going to access at runtime as an inspectable artifact. Incredibly powerful tooling, but from the development perspective, I just get to work with this nice abstraction. I work with NetHTTP. I don't do anything different as a Go developer. And what we generate as those platform dependencies is this declarative manifest. So we can take a look at some of the aspects of this. It's got some auto-generated stuff in there, so don't look at the ID and all that. I think it's amazing. But you can see what we deploy for our key value dependency is this NATS capability provider, so that we'll actually store that that value of the counter in NATS's key value store. And you may have never worked with that before, but we use that for wasmCloud. We also have an HTTP server, and then we actually have an HTTP client and our WebAssembly component. So I want to take you out of the development loop a little bit here and talk about moving a little past that like local platform. So demystifying the wash dev experience a little bit. The first thing that happens is running wash up. So this stands up your local platform. We stand up wasmCloud. We stand up your networking infrastructure and the wasmCloud orchestrator. This is just 3 binaries, right? We're not doing anything wild. We're actually not even running on Kubernetes, but we perfectly can. We can talk about that later. We don't have any applications, and we should have one running wasmCloud host. So this is your local infrastructure. Now, I can actually launch that application the exact same way that we did before with wash dev, with the declarative manifest, and we can deploy that. That's going to stand up all of our infrastructure. And if we run wash app get, once that's deployed, we can do the same kind of curl. So we've taken this developer loop, automatically output an application. This is a pretty bad experience for the wasmCloud community meeting, where everybody has just heard me talk for the last 20 minutes and they didn't actually see what's going on. So thanks everybody for your patience there. So we deploy this application. What's really great is that these capabilities, key value, HTTP, they're all pluggable at runtime. So when we go past using just NATS, for example, say I want to use Valkey or Redis, not going to get into the drama and everything there, but we want to change our key value store to something that we deployed in the cloud. Like I'm using AWS Elasticache. It's got a Redis compatible front end. We're going to use that. So we can actually change these dependencies in our declarative manifest. So we'll change the implementation of our capability from key value NATS to key value Redis. And our latest version, which I had to memorize ahead of time, is 0.28.2. Is great. All of our applications are distributed using the OCI spec, which is just great for reusing existing tooling. And then now the last thing we can do is we can just edit our configuration to connect to Redis. Good job, AI. Look at you being useful for once. Connect to Redis at our localhost endpoint. I don't have Redis running locally, so I'll go ahead and do that. Stand up Redis. And then I can redeploy this application, very much a kube control apply type scenario. And so instead of deploying the NATS key value store connector, we're now deploying the Redis key value store connector. So as soon as my application is deployed, I can hit curl, and you can see that my counter has restarted. And that is because I'm actually storing that value in Redis now. So if I think it's just hello, you can see that it's 4, that's a counter. But the real power of this is that I was able to go through the development loop, use common abstractions, common capabilities like HTTP, key value, incoming and outgoing HTTP, using native Go libraries, compile to a WebAssembly component. And this is the entire bit of code which makes up my microservice. It doesn't have anything about the HTTP port that I want to listen on. It doesn't have anything about authenticating or connecting to my local Redis database. It's all this interface-driven development that developers can work with, a very nice abstraction. And then when you deploy on a platform, we can actually plug in those capabilities and configure it properly for the relevant platform. For locally, it's different than QA or production. So this is a kind of a broad look at what it looks like to develop a WebAssembly component from Go, using the kind of wasmCloud tooling, the local development platform provisioning. And I think that there is a lot to learn there about the experience that we can provide for developers and for platform engineers in cloud native today. Now, all of this is powered, again, by this great marriage of Wasm native tooling and cloud native tooling. So really, I think what is so key to why wasmCloud has blown up as a project over the last couple of months is our commitment to standards first and extensibility in every piece of the infrastructure. So we focus very heavily on implementing and supporting and contributing to WebAssembly standards wherever possible. We have a couple representatives from the WebAssembly standards body in the audience now, and so I hope they agree with what I'm saying. We have a strong commitment to not reinventing the wheel when it comes to cloud native. All of our WebAssembly components sourced from OCI. We run on Kubernetes perfectly well, but you can also extend past where Kubernetes can go in a highly distributed environment. We're completely OTel observable and output using cloud events. As I'm saying all of these projects, I'm realizing that I'm in the place where all of these projects are standing in front of me. So anybody, NATs, cloud events, OpenTelemetry, open feature, we're looking at y'all too. I hope to talk to you after this. And what you saw during the demo is essentially this mode where we can take a binary, execute it in a deny by default sandbox, but provide very powerful capabilities using the WebAssembly component model. I really don't think that I don't have enough brain space to call out all the hardworking people who work to actually make this happen. But I want to specifically shout out the wasmCloud community for getting us to this point. You guys are awesome. The WebAssembly community and the hardworking people at the Bytecode Alliance who are contributing to the Bytecode Alliance. For everybody who's going to be here at the conference, thought this was interesting and want to learn a little bit more, please come to our Contrib Fest session. This is going to be in room 355D tomorrow during the Contrib Fest session, but there's not that many. So if you search Contrib Fest, look for collaborative WebAssembly creation with wasmCloud. Please come by, meet the maintainers, the community. And then last but not least, if you're interested in trying this out yourself, what I ran through today is basically a modified version of the first thing you would do with wasmCloud. So check out our quick start. Join us on Slack or come say hey in the CNCF Slack. I don't know. I think that's all she wrote. Thank you all for coming and hanging out. All these cool people who sat here in the front row to listen to my demo, I think, yeah, do the wave, please. You all get a t-shirt, come hang out and ask me questions after too. I want to, we're here to talk about the project. So thank you all very much. And thank you for being a part of your first, we can do this. We can do a little like mirror inception. Thank you for being a part of your first wasmCloud Community Day. All right, everybody, have a great conference.